Namaskaram students. In this thermodynamic lesson, today we are going to see the zeroth law, first law of statements, mathematical statements of first law. Next enthalpy. Enthalpy symbol is capital H. Next relationship between enthalpy and internal energy. Enthalpy symbol is capital H and internal energy symbol is capital U. Next, this delta, the triangle is called as delta, that is delta means change, and this degree standard, and this F means formation, and this H indicate that it is a enthalpy. So this symbol indicate that it is a standard enthalpy change of formation. Standard enthalpy change of formation. Next, this one is standard enthalpy change of reaction, or means reaction. Next, we are going to see the enthalpy change of combustion, enthalpy change of solution, enthalpy change of neutralization, enthalpy change of fusion, enthalpy change of vaporization, enthalpy change of transition. Rest of the lesson in PPT.
Zeroth law of thermodynamics. See the diagram. B and C consider as a system. The B system containing 400 Kelvin, C system containing 600 Kelvin, and both are separated. Separated means it is isolated, and the one common system, the A system, is common system for B system and then C system. Okay, now the temperature, what will happen for A? Slowly the temperature from B to A will transfer. The same way C to B also transfer. So all the one now attain the thermal equilibrium, all the one having the same temperature because of the A system. The A system commonly they are sharing their between the B system and C system, so that they attain the same temperature. This statement is stated by the zeroth law. Now see the law. If two systems are separately in thermal equilibrium with the third one, then they tend to be the thermal equilibrium with themselves. This is the zeroth law of thermodynamics, and this law is known as law of thermal equilibrium, and this principle only we are using in thermometer. First law of thermodynamics, it is known as the law of conservation of energy. That is, one energy is changed into another energy, so it is energy is saved, so that it is called as law of conservation of energy. In this first law, it is stated that the total energy of the isolated system means separated system, remains constant. The energy changes we consider as the internal energy changes. Internal energy means symbol capital U. So initial state we consider as U1, and final state the internal energy is U2. So changes in internal energy we calculated by U2 minus U1. Then the internal energy changes based on the heat absorption or heat evaluation, work done on the system or work done by the system. So based on these two, heat and work, the internal energy is calculated. Then the total energy remains constant means the mathematical statement of first law, we say that delta U is equal to Q plus W. The Q is the positive quantity, means the amount heat is supplied to the system, that is heat is absorbed by the system. Energy is added, so added means positive quantity for Q. And then work also positive quantity, means the work is added on the system, that means work done on the system, so the work also positive quantity. So we can say that the mathematical statement of first law is delta U is equal to Q plus W. Other statement of thermodynamics. The first statement, the energy is disappear, but the equivalent amount of the same energy is not same energy, the different energy is produced. Now see the diagram, each energy, the chemical energies disappear, but the same amount of another type of energy, mechanical energy, is produced. The same way in all the diagrams, one form of energy is disappear and equivalent amount of another form of energy is produced. The second one, the total energy remains constant. Remains constant means the system and the surroundings, they are exchanging the energy, so that the total energy is remains constant. And third one, energy neither be created or nor destroyed. That means it is not created, already we have the energy, that energy is converted into another form of energy, the conversion only important here. And fourth one, the change in internal energy, we already we have seen in the previous slide. The internal energy we calculated with the help of heat and work, that is equal amount of energy, energy passes through the boundary, heat or work. Now only that only we are calculating the change in internal energy. So we can change the internal energy by changing the heat and work. So heat and work, only two forms of systems to change the internal energy of the system. Now we are going to see the mathematical statement of first law. We know very well the mathematical equation for the first law is delta U is equal to Q plus W. Case 1, in this one we are going to take the cyclic process. Cyclic process means initially one system undergo so many changes, afterward it reaches the initial system, so that the initially what they are having the same way, final also they having the same amount, so that the delta U value, internal energy, initially you have it has some energy, and finally also the same energy it possesses, so that delta U equal to value 0. Now you apply the delta U value 0 in the equation 7.7, you get the Q equal to minus W. What is Q means? It is a positive quantity, that is heat absorbed by the system. Absorbed means energy is added to the system. Then minus W. Minus W means minus quantity means work is done by the system. So whenever the system work done means it loses some energy, so that the minus quantity we are putting there. So Q equal to minus W for cyclic process. And case 2, isochoric process. Iso means same, core means value. So same value means that initially and finally we have same value. So delta V value equal to 0. And then the delta U, we know very well the formula is Q plus W. In the first see the equation 7.7, and in that one W value is minus P delta V. Here we are going to consider the pressure volume work, so that you put the minus P delta V here, and delta V it is 0, so that we put the 0 value there, means we get delta U value Q, and that we indicate that it is at the constant value. So now the change in internal energy we brought by heat supplied to the system in the isochoric process. Case 3, adiabatic process. What is adiabatic process means? In that process the heat is never changes. So Q value 0, put the Q value 0 in the equation 7.7, we get the delta U value as a W. Here W as a positive quantity. Positive quantity means the work done on the system, so there is the changes in internal energy. The next one, case number 4, it is an isobaric process. Iso means same, bar means pressure, so same pressure, the pressure value never changes here. Then the delta U value is Q plus W. Here W work is we consider as a pressure volume work, so put the W value minus P into delta V, and P value constant, the same here also constant only. So delta U value is equal to Q minus P into delta V. There is no 0 value, girls, keep it in mind, don't put 0 for p. P value constant here. P value never becomes a 0 here. So keep it in mind. And then here the Q value is positive. Positive means the heat is absorbed by the system. Even though the heat is absorbed by the system, a small amount of heat is used for that PV work, so that the remaining amount of heat only used for internal energy. In this problem, the external pressure is given as 1 atmosphere, and then the volume changes from 5 liters to 10 liters. So 5 liter is the initial volume and 10 liter is the final volume, and some amount of heat, the 400 joule amount of heat is absorbed by the system. So heat is 400 joule. So what are the data given means pressure, initial volume, final volume, and heat. So that data are given here. First of all, delta U value Q minus W. Why we are putting Q minus W means Q is the heat absorbed by the system, so that positive quantity, and work done by the system, so negative quantity here, and then work in the form of we are considering as PV work, that is pressure volume work. So Q minus P into delta V, and P value 1 atmosphere, and volume changes from initial to final. Final volume is 10 and initial volume 5. Put the 10 minus 5 means we get 5 liter, and then 5 into 1 we get 5 atmosphere liter here, and then 1 atmosphere liter is 101.33 joule. So 5 atmosphere liter means we get 506.65 joule. Then the 400 joule minus 500 joule means we get negative quantity of 106.65 joule for internal energy change. Enthalpy. Enthalpy means it is the internal energy is added with the product of pressure and volume. So as per the equation, H is equal to U plus PV. U means internal energy of the system, and PV means product of pressure and volume. It is the sum of internal energy of the system and product of pressure and volume of the system. But one condition here, this equation for only at constant pressure. Keep it in mind, the pressure is constant for enthalpy value. And here the internal energy U, pressure, volume, all these quantities are state function. So enthalpy also it is a state function. Now see that A is a one system, that is initial state, changed into B system. That B system is final state. Initially the enthalpy value is H1, and in B system the enthalpy value changed into H2. The same way internal energy and volume, it is changed from U1 V1 to U2 V2 in the final state. But in this one the pressure volume alone constant, the pressure volume never changed. Now the H2 minus H1, that is final to initial, we get some amount of change in internal not internal enthalpy. The same way U2 minus U1, there is change in internal energy, and then P into V2 minus V1, that is change in volume, so P into delta V. Now we can write the 7.8 equation as a 7.9. What does that mean? Delta H is equal to delta U plus P into delta V. Here the P volume is never change. Why? Because it is a constant value. Now the delta H value, after calculating that, we get QP. We will see in next slide how it is changes into QP. What is QP means? It is a heat at constant pressure. Endothermic reaction. What is endothermic means? The heat is enter into the system. So heat is added, heat is absorbed by the system. So heat quantity is positive quantity. So the delta H value also positive quantity. In exothermic process, what is exo means? The heat is exit. So heat is going out. The heat is evolved by the system. So energy is losses. So energy losses means negative quantity for Q. So Q value negative means delta H value also negative. Relationship between enthalpy and internal energy. We already saw in the previous slide the A system. Initially it is A system, and then changed into B system, that is final state. Then initial state, H1 U1 P1, they are having the initial state, and then H2 U2 V2 are in the final state. The pressure value alone not changes, we already saw in the previous slide. Then enthalpy equation, as per the enthalpy definition, enthalpy is equal to, it is a sum of internal energy and the product of pressure and volume. So H is equal to U plus PV, and initially what we are having, H value H1 and U value U1, and P value never changes, so P, and V value is V1. So equation 7.10, like that we are getting. In the final state, what is the equation is H2 equal to U2 plus P V2. All the one is changed into final state except the pressure value. So equation 7.11. Now we are subtracting the 7.11 to 7.10. So H2 minus H1 is equal to U2 minus U1 plus P into V2 minus V1. The changes value we can write is at here, delta H is equal to delta U plus P delta V. Here P value never changes. So this is the equation 7.12. And then we already know that from the first law of thermodynamics, in change in internal energy we get from the Q plus W. Both are positive quantity. You apply this equation in the equation 7.12. Write the equation delta H is equal to, instead of delta U value, Q plus W we are putting, and then PW, P into delta V from the equation 7.12. Here the W is, what is that means? It is the pressure volume work. So we put the pressure volume work here as the W is equal to minus P into delta V. Put the value there, both are cancelled. Afterward we get delta H value is equal to QP. What is QP means? The pressure value constant here, and heat is absorbed by the system. So delta H change in enthalpy we are getting from heat absorbed by the system at constant pressure. Consider a closed system containing gases. These gases at constant temperature and pressure. The volume of gases initially Vi, and finally the gases volume of gases are Vf. The same way, Ni is the number of moles for gases at initial, that is reactant side, and finally that means product. The product number of moles is Nf. Then ideal gas equation is PV equal to nRT. In that equation, the pressure value, the temperature value, and then gas constant value, three value are constant value, but what are the changes means number of moles and volume alone, the value alone changes. Now as per the equation, first what is the initial? Initial means the PVI is equal to NIRT. I means what pa? Initial value. So initially volume is Vi, the same way initially number of moles is Ni, but all other value constant. Then product, final state is the product. Then product changed is the volume is changed as Vf. Then number of moles also changed as Nf. So put the value here, we get PVF is equal to NFRT. Now the equation 7.15 subtracted to the 7.14 is subtracted from the 7.15, we get P into Vf minus Vi is equal to Nf minus Ni into RT. Then the Vf minus Vi we can write as delta V. Then Nf minus Ni we have changed as a delta Ng. The G is represented that it is a gases. So for the gases alone we can calculate the number of moles changes. So P delta V is equal to delta Ng RT we are getting in the equation 7.16. This equation we can substitute into equation 7.12. What is 7.12 means? Delta H is equal to delta U plus P into delta V. Here instead of P into delta V, we put the delta NGRT. From the equation 7.16, we get the equation for enthalpy of the gases is delta H is equal to delta U plus delta NGRT. This equation for gases. Standard heat of formation. Before seeing that definition, first of all see the equation. First equation, FeS. FeS is the ferrous sulfide compound. That compound formed by the Fe plus sulfur. What is Fe means? It is the element, iron element when combined with the sulfur element, and then it gives the FeS compound. In that FeS compound, the amount of energy, some amount of energy evolved means negative quantity. So delta HF0 is equal to negative 100.42 kilojoule mole minus 1. Here FeS 1 mole alone we are going to produce with the help of iron element and sulfur element in their standard condition. Standard condition means it should be in the temperature 298 Kelvin and 1 bar pressure. That is called a standard heat of formation. What we are going to form here, ferrous sulfide compound is formed, and how many amount means 1 mole amount only we are going to form. The same way, another example, 2 moles of carbon combined with 1 mole of hydrogen, it gives 1 mole of acetylene, C2H2. So that formation of 1 mole of acetylene, the amount of heat is absorbed. Positive quantity is given here, 222.33 kilojoule mole minus 1. That is called a standard heat of formation of acetylene. But here the carbon and hydrogen are element, so the standard heat of formation of carbon and hydrogen are 0. Always the elements heat of formation is 0, but compound heat of formation have some amount of value. That value may be a positive quantity or negative quantity. The same way in third example, half mole of chlorine combined with the half mole of hydrogen, it gives 1 mole of HCl. That 1 mole of HCl, the some amount of energy is evolved. Minus quantity is given, minus 92.4 kilojoule mole minus 1. Even though that chlorine and hydrogen are elements, so elements means standard heat of formation of chlorine and hydrogen are 0. Here the definition is the change in enthalpy take place when 1 mole of compound formed from its elements. That element should be in the standard state. What are the standard state means? 298 Kelvin and 1 bar pressure. Standard enthalpy of the reaction. What is reaction? Reaction means reactant combined with each other give the product. Now see the last one general reaction I gave here. The A mole of A plus B mole of B reacted with each other. These are the reactant and give the product. What are the product we are obtaining means C mole of C and D mole of D. For that one we are going to calculate the enthalpy change of the reaction. So for the reaction we have the product as well as the reactant. So first product, the summation, how many product we are having? 2 product. The 2 product enthalpy changes we have to add, that is summation minus and summation of enthalpy changes of the reactant. How many reactant we are having? 2 reactants. So the 2 reactants we are going to add. Now the last equation, see that the delta H reaction standard is equal to C moles. How many moles for the C product? C moles we are having. So C moles multiply with what are the delta H value is given, that is multiplied, plus, and D for the D product, what is the mole there? D moles. So D into delta H of 0, D minus A moles of A reactant, so A into delta H of A plus B mole of B product, B reactant, so B into delta H of B. This is the equation for delta, that is standard enthalpy of reaction. In this one, all the reactant and product should be in the standard state only. What is standard state means? Temperature should be 298 Kelvin and pressure should be 1 atmosphere pressure. In this problem, the equation, see the equation C2H5OH, that is ethanol, it combined with the 3 mole of oxygen and it gives 2 mole of carbon dioxide and 3 mole of water. Then here the oxygen is the element, so that the enthalpy formation of oxygen is 0. Now see in the right hand side, the ethanol, what is the value is given means tetrahedral formation. The enthalpy change of formation is given as minus 277. For oxygen it is a element, so 0 value. And then carbon dioxide in the form sum they given us the delta H formation is minus 393.5. And for water also the delta H formation is given as minus 285.5. Now equation delta H reaction standard enthalpy change of reaction is equal to standard enthalpy change of product minus standard enthalpy change of reactant. What are the product here? Carbon dioxide and then water. How many moles of carbon dioxide? 2 moles. So 2 into that value you have to multiply. And how many moles of water? 3 moles of water. So 3 into and water amount minus 285.5. And then these are product minus reactant means reactant, what are the reactant? Ethanol and then 3 moles of oxygen, but oxygen value is 0 here because it is an element, but the ethanol value given us minus 277, so 1 into minus 277, that value we get afterward calculating, we get the value delta H standard enthalpy change of reaction is equal to minus 1366.5 kilojoule. Heat of combustion. Combustion means what? Any substance burned in presence of oxygen, that reaction is called as combustion reaction. In this one, the 1 mole of substance is completely burned in air or oxygen. What are the enthalpy of the system is changes, that is called as heat of combustion. Now see that in the example first one, methane is burned in presence of oxygen, gives carbon dioxide and water. Here the heat of combustion is minus 87.78 kilojoule mole minus 1. Then combustion of carbon means the carbon in presence of oxygen, it is burned means it gives carbon dioxide. In that reaction the delta HC, C means combustion, H means enthalpy. Enthalpy change of combustion is minus 394.55 kilojoule mole minus 1. The both example we have the negative value. Why we are negative value means combustion reaction always exothermic. Exothermic means value evolved, the heat value evolved. Evolved means energy losses. So losses means negative quantity only we will give. So heat of combustion is always negative value. Solution means what? Solution we get from the when solute dissolve in solvent. So when the one solute is dissolved in solvent, it produce solution. Sometimes it absorb the heat from the surrounding. Sometimes it evolves some amount of heat to the surroundings. So here heat of solution is defined as change in enthalpy when 1 mole of substance is dissolved in specified quantity of solvent. Not any amount of solvent, specified quantity of solvent at a given temperature. That enthalpy change is called as heat of solution. Now first see the example. HCl. HCl is the acid and KOH, potassium hydroxide, it is a base. Both are combined gives potassium chloride, that is salt, and then water. It is a neutralization reaction. Why it is called as neutralization means acid, one of the character, that base is the opposite character of the acid. So when the both opposite character meet each other, it neutralize. So it is called as neutralization reaction. In this neutralization reaction, now see the definition. What is the heat of neutralization is? It is defined as the change in enthalpy when 1 gram equivalent of acid is completely neutralized by 1 gram equivalent of base. The same way when 1 gram equivalent of base is completely neutralized by 1 gram equivalent of acid, there is some change in enthalpy that is called as heat of neutralization. Here the heat of neutralization for acid and base, always we get the some constant amount. What amount means minus 57.32 kilojoule. Why we are getting this minus 57.32 kilojoule for acid and base neutralization means, we will see the example. In this example, first example, hydrochloric acid, potassium hydroxide used. For that also delta H value minus 57.32 kilojoule. And the next one, potassium hydroxide is added with the nitric acid. HNO3 means nitric acid. In this nitric acid also we get the delta H value. See the delta H value minus 57.32 kilojoule. The next one, H2SO4. H2SO4 means sulfuric acid. Sulfuric acid is added with the potassium hydroxide. We get the same delta H value minus 57.32 kilojoule minus 1. Here the potassium hydroxide is same, but we change the acid. First HCl acid added, next nitric acid is added, next sulfuric acid is added, but potassium hydroxide we are commonly used. Even though we are commonly used, we change the acid. So the delta H value also will change, no, but here there is no changes in delta H value. We get the same constant value for delta H. Why we are getting means, we get the delta H value from the H plus, that see the last equation, water. What is the common product here? Water is the common product. So water common product, how we get means, that is H plus plus OH minus combined with each other gives the water. That water quantity when it give means, it produce some amount of heat. The amount of heat is lost. How many amount of heat loss means minus 57.32 kilojoule. So that amount only we are getting, where whatever acid is changed with the base or whatever base changed with the acid, we get the same heat of neutralization value as minus 57.32 kilojoule mole minus 1. This one only for strong acid and strong bases. Molar heat of fusion means 1 mole of solid converted into liquid at its melting point. What amount of heat is evolved or absorbed, that is change in enthalpy, that is called as molar heat of fusion. Now see the example, water H2O, it is in the solid state. S means solid state. In the 273 Kelvin, it is changed into water H2O, the same water, but L means liquid state. So the ice cube changed into liquid state, that amount of energy, some amount of energy is absorbed. What amount of energy means plus 5.98 kilojoule. That is called as molar heat of fusion for water. Molar heat of vaporization. Here see the example, water H2O, bracket in bracket L is given. L means liquid, water in the liquid state. In when the temperature 373 Kelvin means, that is changed into water vapor. V means vapor. So in that water from the liquid state to vapor, some amount of heat is absorbed, that is 40.626 kilojoule is absorbed. So that is called as enthalpy of what is heat of vaporization, and H means enthalpy only, but the change in enthalpy we get when 1 mole of liquid is converted into vapor state at its boiling point. That boiling point we have to mention that. Before that we are see that heat of fusion. In that fusion we have to put the melting point, but in vaporization we put the boiling point. In boiling only the water is changed into vapor. Now heat of transition, see the example. First example, carbon diamond state, carbon in the diamond state, then the product side carbon in the graphite state. Both are carbon, but first carbon is diamond and second carbon is graphite. So there is change in allotrophic form. Some amount of heat is absorbed. plus 13.81 kilojoule. Both are in 1 mole only. So the change in enthalpy when 1 mole of element changes from one form of its allotropic form to another form of allotropic form, that is called as heat of transition. The same way, another example, sulfur, it is in monoclinic form, that is changed into sulfur in rhombic form. There is some amount of heat is evolved, that is negative 0.067 kilojoule, that is called as enthalpy change, that is delta H transition. And P means phosphorus. The white phosphorus changed into red phosphorus. Both are phosphorus, but the allotropic from one form to another form changes. In that one, the some amount of heat is evolved, minus 4.31001 kilojoule, that is called as heat of transition.